So now we are going to do synchronous counter mod 6 using SR flip-flop. Now when we are showing mod 6 counter, the counter is changing 6 states, 0, 2, 3, 6, 5, 1, 6 states it is changing, and the state diagram of the counter is there in front of you. Using SR flip-flop is required for this question now. So now we have to also understand the application table of SR flip-flop. Application table means that what should be the input of the SR flip-flop to change the state from 0 to 1, 1 to 0, 0 to 0, or 1 to 1. So because I have one output and I have two states, I have only one output Q and I have possibilities of two states. So there will be 4 rows here. So if present state is 0, if present state is 0 and next state also I want to make as 0, this is one of the case. Next, if present state is 0 and next state is changing to 1, that is second possibility. Then present state is 1, next state I want to make it 0, third possibility. Fourth possibility, if I have present state as 1 and next state also I want to make it as 1, that is my fourth possibility. So if I have one output and two types of states, 0 and 1, there will be 4 possibility. So application table of SR flip-flop will tell me what should be the input of SR flip-flop if I want to apply SR flip-flop for any one of these 4 changes. So you know that 0 to 0, 0 to 0 means no change, means it can be a memory state, right? And what is the SR input for a memory state? Tell me, what is the input for the memory state for SR flip-flop? If I want to use SR flip-flop as memory, what should be the input of SR flip-flop to keep it as memory?
0 1 ma'am.
0 1.
Sorry, 0 0 ma'am.
Yeah, memory state means it is 0 0. And if I want to keep my next state as 0, this is also can be taken as resetting of the flip-flop, and resetting output as 0 means resetting. So for resetting, the input of S and R is 0 and 1, correct? So 0 and 1 input of SR flip-flop will make it to reset to 0, one possibility. Other possibility is if S and R both are 0 0, it goes to memory state and 0 will remain 0. So the possibilities is S will be 0 and R will be don't care. So 0 and 0 memory, 0 and 1 reset. So these are the two possibilities. Now coming to the next row, 0 to 1. 0 to 1 means my next state has become 1. So it can be the setting of flip-flop, right? And if I want output as 1, it is like setting of the flip-flop. And setting of the flip-flop input says 1 and 0. Do you think any other possibility is there if I want to make the output as 1? There are no other possibilities. It is only setting of the flip-flop which can make the output of 1 from 0. There is no toggle in SR flip-flop, no, so it can't happen. Coming to third row, when my output is 0, means what? I am resetting the flip-flop. And if I am resetting the flip-flop, the input for resetting is a reset pin should be 1. Resetting should be happening. So 0 and 1 resetting is happening. So second and third, so second row is setting, third row is resetting of the flip-flop. Now coming to the last one. Last one says what? 1 was there and 1 remains. So when output is same as previous state, then it is one case of memory. So memory means, as we have seen in the first case, memory means 0 and 0. But one more possibility is there. Output can be 1 in case of setting of the flip-flop also. So S can be a don't care and R can be a 0. So if S is a don't care, R is 0 means what? 0 and 0 will be memory state. 1 and 0 will be set state. So this is the application table of SR flip-flop. Now we have to make our excitation table. Excitation table, the present state and next state will be made from present state and next state will be made from your this state diagram, and your flip-flop input will be made from using this application table. Okay, so I need a lengthier space. Okay, so I will use this bottom of the page now. So we have to see present state, then we have to see next state, then we have to see how many flip-flops are required. If I have 3 variable counter, you can see this is maximum is 6. 6 can be made from 110. That means it is a 3 variable counter. 3 variable counter. That is why I am writing Q1, Q2, Q3 and Q1 plus, Q2 plus and Q3 plus. So if present state is 0, 0, 0, that is I'm starting from this 0. If present state is 0, 0, 0, next state is 2, right? 0, 1, 0. So that I have to complete it. If present state is 2, next state is 3. If present state is 3, next state is 6. Right? 6 means 1, 1, 0. Right? Then if present state is 6, next state is 5. From where I am doing this? I am doing this from state table only. Now, if present state is 5, next state is 1. That is 0, 0, 1. Next, present state is 1. Then next state is 0. Now my present state and next state, this is complete. Right? Now I need to bother about the excitation input. What should be the flip-flop input to change this? I still did not get my answer which I asked you people. I am repeating things and then also you are not answering. How many flip-flops required?
3 SR flip-flops, ma'am.
Yeah, 3 flip-flops are required. You people should answer, okay? It does not look good in online class if I don't get answers. So if I have 3 Q1, Q2, Q3, so to give me these 3 Q1, Q2, Q3, I need 3 flip-flops. So one by one, I will have to design my each one. So S1, R1 will be taken as my first flip-flop input, whose output is Q1 plus. S2, R2 will be my next one, which will be my second flip-flop input. And S3, R3 will be my third flip-flop input, which will also take care of my change from Q3 to Q plus. So these are my inputs, right? Now I should start with the Q1 to Q1 plus column. Now your application table is here, which you can refer to do this work. Now I will be concentrating. You can put 2 fingers, one on Q1 and one on Q1 plus, and carry on. Otherwise, your parallax error of your eye will change your answers only. Keep 2 finger, one on Q1, another one on Q1 plus. Then what you see, the first thing is 0 to 0, 0 to 0. And you know that 0 to 0 means the SR input is 0 and dash. So you have to do like this only. 0 to 0 is 0 dash. Next is what? 0 to 0 again. So again it is 0 dash. Next is what? 0 to 1. Can you see what I'm saying? 0 to this 1. 0 to 1. 0 to 1 is 1, 0. Any one of you can unmute yourself and answer along with me. So 0 to 1 is 1 0. Next is 1 to 1. What is 1 to 1? 1 to 1 is this dash 0. So 1 to 1 is dash 0. Next is what? 1 to 0. 1 to 0 is what? The third row. So 1 to 0, if you want change from 1 to 0, SR should be 0 1. So 1 to 0 means SR is 0 1. Last one is what? 0 to 0. So 0 to 0 is again same, our first row here, 0 dash. Is this clear? Is this clear?
Yes, ma'am.
Yes, ma'am.
Okay, now coming on to same way you have to do S2R2. Now when you do S2R2, you should keep one finger on Q2, other finger on Q2 plus. So when you do Q2 to Q2 plus, you have to again follow the same. Now I am copying it. Okay, so Q2 to Q2 plus 0 to 1. 0 to 1 means 1 0. Next one is 1 to 1. 1 to 1 is dash 0. And I am doing so on. Next one is also 1 to 1. Next one is what? 1 to 0. I hope you people are able to relate what I am saying. 1 to 0 is 0 1. Right? So I have to do next one 0 1. Next one is 0 dash. And last one is again 0 to 0. So 0 dash. Right? In the same fashion, you have to do S3R3. Now it is a repeat. I am simply writing. You verify whether what I am writing is right or not. So next you have your 1 0 dash 0 and 0 1. Is this part clear? I have got my S1 R1, S2 R2, S3 R3. Now for each one, what I am supposed to do? Your S1 R1, S2, R2, S3, R3. You have 6 excitation input. 6 excitation input. And all the 6 excitation input is made from, you have to make the logic diagram for this. And it is made from what? It is made from your present state. So what it is? These excitation inputs, these 6 excitation inputs are used to change the state from this present state to this next state, right? So this is a function of present state only. So this is a function of present state. And what is your present state made up of? Present state is made up of Q1, Q2, Q3, right? Present state is made of Q1, Q2, Q3. So you have your 6 equations where it is depending upon your present state, and you get your next state as output. So input is present state, output is next state. And how do we do this? We do this by using our flip-flop excitation input. Okay, so this is now what you have to do. You have to start making your K-map. Start making your K-map. So K-map means after. So now what is required? We have to make K-map, right? We have to make K-map. Now K-map, what is the K-map? How many K-maps I will have? You want me to make K-map or you will do it on your own? Yes, answer me. You want me to make K-map?
From here we can do it.
You can do it K-map?
Yes, ma'am.
Okay, so I will simply write it for completeness. I will not solve completely. It is Q1, Q2, Q3. So I am talking about S1 now. And S1 means you have to take 0, 1, 2, 3, 4, 5, 6, 7. So you have your these things, and I am writing for S1. So you should see S1 column. If you see S1 column, you can see 1. This 1 is for 3, right? Present state 3. S1 column you have to see. Maybe if anybody else have doubt in this, I am doing it. Okay. S1 if you see, 1 is there for 3 and don't care is there for 6. So I have to search 3 cell and put 1, 6 cell and put don't care, and rest all are 0. Okay. So 3 is 1. 3 is a 1 and what is a don't care? 6 is a don't care, right? Which one was don't care? Yeah, 6 was don't care. So this is a don't care. And because in my truth table, you can see that in my state also you can see there is no 4, there is no 7. So this 4 and 7 cell will also be a don't care. 4 and 7 cell will also be a don't care, and rest all cells were 0. Rest all cells were 0. So now when I do the grouping, I will have only one pair like this, and this is equal to, if you have your so what is this column? This column is Q2, Q3. Q2, Q3, this is your 1, 1. So Q2, Q3. So S1 is your Q2, Q3, right? So what I did S1 column, I took S1 column and I made this K map, and I took this S1 column, used this. So this S1 is the this S1 is the output, and input is Q1, Q2, Q3, and you have made many such K maps before also. In the same fashion, we will be getting our R1. We will be getting our R1. In the same fashion, we will be getting our S2, R2, S3, R3. So means you will have your one K map for R1 column, another K map for S2 column, another K map for R2 column. Like this, you will have your 6K map and you will get 6 equations. And which nicely you people had given me in the previous Google Classroom answer, copy paste answers. You all had given me right answer, which is also there in the book. So you are getting these answers, which you should do using K-map only. Okay. Next, what you do, you make your circuit. You make your circuit, and how do we make our circuit? I am doing this only to complete this answer. So what do you have? You have 3 SR flip-flops, 3 SR flip-flops, and you have your input here S1 R1, S2 R2, S3 R3, and you will have your output also Q1, Q2, Q3, and you will have your clock also, because it is a synchronous counter, synchronous state machine. So this will be your count pulse. You should write here C for clock. C for clock. You can say here as count pulse, or you can also say that it is a clock. Next, S1 R1 is equal to Q2 Q3. This S1 R1 S1 is Q2 Q3. So S1 input will come from S1 input is a NAND gate of Q2 and Q3. So I will have one input of this AND gate coming from Q2, and another input of this AND gate is coming from Q3, right? This is my Q1, Q2, Q3 output, and I am connecting. R1 is what? Q2 bar. So you know or along with Q2 you have your Q2 bar also. So what do? We simply connect Q2 bar to this R1. Connection over, because I had a Q2 bar already with me. Next is Q1, Q3. Q1 bar, S2 is Q1 bar, Q3 bar. So what you will do? You will take Q1 bar from here and you will take Q3 bar from here. So Q1 bar, Q3 bar, put in AND gate and put in this S2. What is R2? R2 is Q1. So easily we can do this connection. So you know that when everything is there with you, you can do the connection easily. So this Q1 is going into R2. I can show like this. This Q1 is going into R2. So on, and you can complete your question like this. Okay, is this clear then? Anything else you required from this?
Ma'am, I had a doubt.
Yeah.
Yeah, tell me what is the doubt?
Ma'am, so if